Hey everyone, we're making a wearable device that utilizes Bluetooth Low Energy technology that captures your motion while being both affordable and power efficient.
The idea is to use multiple sensors to keep track of your activity over time. It'll be able to distinguish between activities such as sitting or running. These activities will be transmitted through Bluetooth to a central device like a cell phone. And using beacons, we'll be able to keep track of your position within range of a building. And that is when Kino project comes along.
Hi, my name is Sergio. I'm in charge of the hardware aspect of the Kino project. I'm leading the PCB design for the motion capture device. I am working with Marjan, Kevin, and Aaron.
I'm Ken Saisu. I'm working with Ricky, Garmin, and Sean, and we are currently working on the firmware and the ITC drivers for the accelerometer, gyroscope, and magnetometer.
Hi, I'm Danny, and I'm working on the Bluetooth Low Energy, and I am transferring sensor data over to a device.
I'm Xiao. Hi, I'm Ricky.
Hi, I'm Garmin.
We've been writing code that uses I2C to read data from the accelerometer and displays the converted data onto the PSOC LCD screen.
So I've been able to get the buffer to work on the accelerometer, and you can see right here that this is about 96 samples of X, Y, and Z data being passed in. And you can see over here that I have the interrupt line going high right when the buffer gets filled, and then I read it out and it becomes low again. Reading the buffer was a bit of a challenge because the Cypress library was a little bit off. It wasn't doing what I needed it to do, so then I had to rewrite the function so I can have more manipulation over the I2C timing diagram that I match up with.
Hi, I'm Kevin, and I'm part of the PCB design group. And right now I'm working on the schematic and then eventually the breakout board for the power board. And this is the schematic what I'm putting together, where this is the USB, this is the fuel gauge, this is the battery charger, that's the voltage regulator, and this is the battery plug. And then we're putting all 5 of them together into one board.
Hi, I'm Aaron. I made the breakout board that combines the accelerometer, the magnetometer, and the gyroscope. And I pretty much put it onto one breakout board and submitted to Osh Parts for it to get fabricated.
Hello, I'm Marjan. I'm currently working on the voltage regulator. So we picked this voltage regulator on Mouser Electronics website, and looking at the data sheet of this component, I look at the pads and pad dimensions, and I created this schematics. I have worked on this package.
Alright, so I'm working on the breakout for the PSOC that interfaces with the power board that Kevin talked about and the sensor board that Aaron talked about. And this is pretty much what it's going to look like. I mean, I have the antenna coming out right here, the actual board or the processor right here. You got the crystals, you got the pins are going to be connected to the breakout board or the proto board. And I've included LEDs just to, and for debugging purposes.
This is the PSOC BLE module, and I made a custom service that sends random data over when notified. I could stop it when I'm reading or stop. Land on a random number.
In charge of the hardware aspect of the Kino project. I am I want to say in charge again.
On the front side is when I saw your face,
Dude, that's right on. Oh my god! Dude, that's right on. Oh my god!